have a better idea of what you have to study. So as I tell you, I'm going to make that list first, go over the concepts for the most part, and then we're going to do simple exercises that help you understand those concepts a little bit better. I'm going to post, then the test is going to be taken on, it's going to be available on Friday. You have to do, but hopefully just prepare to take the test on Friday. And the best way for you to know what is going to happen on the test is, as usual, use the practice test as a reference. That is my advice to you, usual. So I'm not going to change that course of action. The only different thing is that this time we're going to do it online, but you already know how it works because we did it by the end of the second term. And in my opinion, I didn't know in that time that we were going to have to do it this way. So I think that that was a very good, that's, I think, something you have, in your face. I'm going to put it in front. All right, so the list theorem, right? With this, I think there are two things you need to know, okay? And it's this, that the two ways we can manipulate the formula, depending on what missing information you have to find out. And he said this is a repetitive pattern. You are given certain tools, but every single time you will need to use those to find missing information. But beyond that, it's about you getting more and more familiar with that concept every time, okay? All this way of us working it. Okay. So, Pythagorean theorem, all right? We have right triangle. We have A, B, and C. A and B being the legs, C being the hypotenuse. They are, they have this relationship. So make sure that you use this way or this form, which is the one that we derived in the first place and the one that is more common to everyone. We are going to use this one when we have we're solved for C. I guess that sometimes even better you're going to use it this way. And this one is going to be used when, and hopefully you at home are going to answer, do I use this one? When we need to find out the hypotenuse information from the hypotenuse and one of the legs, and the question is finding the other leg. In that case, we tend to use depending whether you want to find a topic, and if an exercise, a problem situation, you discover that that's what is going to story. Okay, so check this. Now let's continue with the next part. That was just, actually probably I can do it this way as well. Yeah, we have, this is 9.1, all right, now the Pythagorean theorem, all right? Which is special right triangles, okay? So with the special right triangles, what you needed to know is that there are two types of special right triangles. Those where we have interior angles being 45 and 45, right? So in this case, this special right triangle has this particular notion that if the measure, one thing is that for a 45, 45, 90, the measure of the legs is the same because it's an isosceles triangle. That's the principle, and that's how you know it. That's how you know root of 2. Okay, value. So you are going to be given sometimes the value of one of the legs or the value of the hypotenuse and find the other in return. That's all. Okay. The second special right triangle we have is angle. In this case, the short leg, the small square root of. Sometimes you are going to be given the short leg, and finding the other two is really simple because you just have to multiply either root of 3 or 2. But sometimes you are going to be given the value of the long leg, for example, and that makes the problem a little bit more complex, but not impossible. Okay, just keep that in mind, that if you are given the value of the long leg, and if you want to find the value of the short leg, the only thing you have to do is divide by root 3 or divide by 1.73. Yeah, that's it. With that, you will find the short leg, and then whatever value you get, if you multiply by 2, you will get the hypotenuse. All right, but this is all about making sure that you understand the concept, and it is so broken down in your mind that now it's easy for you to go back and forth without any problem. All right, this is all about special right triangles. Right, now let's do 9.4, 9.5. That was, hopefully you remember, the trigonometric ratios, the basic ones, the definition of tangent, sine, and cosine. I prefer sine, cosine, and tangent. Probably it's really important that you know the definition. So remember when I told you about this? Sine is the cosine of an angle, is the ratio of the adjacent segment divided by the hypotenuse. And the definition of tangent of an angle is the ratio of the opposite segment and the adjacent segment to it. You know how to deal with any problem situation or exercise related to the basic trigonometric ratio. Thing is, we have this right triangle. Okay, so this is vertex C. This is vertex O. If I start with angle A, which is this, what is the opposite segment to this A vertex A, or angle A? It's going to be segment A. All right? And this is very important because we need to clarify this every single time so you don't get confused, okay? So for angle A, I can define that the sine of angle A, yeah, we take a look at the definition, opposite divided by hypotenuse, all right? So it's going to be A over C, okay? The cosine of A is going to be B over C because it's the adjacent over hypotenuse, and tangent opposite over adjacent. Determine this for angle B, which is right here on top. There is something interesting, and it's that these values will be switched, and these two will be switched as well if you want to define this opposite of our hypotenuse, which is B over C. As you can notice, cosine of B is going to be A over C, which is adjacent. Now this is the adjacent. Remember, it's about where you're standing. It's your point of reference, and sine of B is equal to cosine of A. All right? And tangent of B and tangent of A are reciprocal, right? You now make sense of all this. These are the, and you can work these out of exercises where you will need to find information. For example, sometimes you are given the value of the angle. Let's say that A is, I don't know, 30. So you say sine of 30, and then you are given, for example, the value of the leg. So find the hypotenuse, right? Which means, and let's solve one of these exercises, okay? That way. Let's say that A is 25 degrees, all right? Angle A is 25. And let's say that A is 15, whatever units you use, let's say 15 units, okay? So with these two pieces of information, let's find C, okay? Find C using this information. So now you know, okay, I have information of the value of the actual value of the angle and the value of one of the legs. But what let's stand here on A. If I'm standing here on A, it means the information that I am given is the opposite to it, okay? Which means that, and if I need to find C, and I think I have opposite, and then I need to find the hypotenuse, though, so sine is going to make sense because it is relating up. Now you will see that sine of 25 is equal to opposite over hypotenuse, which is going to be 15 over C, okay? And sometimes, you know, you do the hardest part because you understand this concept, and sometimes some people, we already know this, hopefully, I mean, why not memorized, you know, but you make sense of that because of the definitions. So I'm going to continue solving that exercise. Let me do it here. Multiply by C, multiply by C. Remember, multiplication property of equalities. With that, I'm going to eliminate this C from here. And now it's going to be here. So let's rewrite it. So C times sine of 25 equals 15. All right? And then the last thing I have to do, can you see that we have a product here? C times this. Remember, they cannot be separated. So sine 25. If now I want to get rid of this sine 25, it means I divide by sine 25. All right? So in the end, C is going to be the result of dividing 15 by the sine of 25. Google, and then I'm going to ask, what is sine of 25 in degrees? Information that Google is giving me, the sine of 25 is 0.42. Okay, are we sure? Just let me make sure, you know, sometimes I just don't trust because they have set it up in a way that, you know, I prefer to do it twice. I don't know. So sine of 25. All right. Nope, I want it in degrees. 25 is 0.4. Okay, 0.42. So this is going to be 15 divided by 0.42, and then, you know, I just rounded to 2 decimal places, so now I just run the division. Divided by 0.42, so I get a 35.7. Okay. All right, that's it. That's how you deal with this type of situations. All right. Hopefully it makes sense now. Okay. Trigonometric ratios on relationships. Okay. Again, I repeat this because this is the way we usually work. You learn a concept, and the way that us teachers make sure that you understand the concept is giving you problems where you have to find missing information. How are you going to find that missing information? Using the concept that you just learned. It works that way almost all the time. For those who hadn't noticed yet, now you know how it works, right? So there's no secret here, right? I just want to make sure that you get this thing and get how things are, right? And when I realized of that when I was at school, I said, like, it was so simple, right? So it's always about that. So, you know, down, you know, it made my life really easy after that when I realized about that. Anyway, so that's it about the trigonometric ratios. The thing is, I think I have to specify something about section 9.6 because probably I did not go as deep as I wanted, and it's about explaining the concept of angle of elevation and angle of depression. But let's start with that section 9.6, okay? So we have that in 9.6, we are asked to do this, solving right triangles, all right? So solving right triangles means that, and we have one here in front of us. So let me adjust this. Okay. So look at this. Remember, with elements of the usual or basic elements of right triangles or triangles in general, but for the right triangle, we have the 3 segments, the 3 sides, and the 3 angles. As soon as I tell you right triangle, you immediately know the value of one of the angles, which is 90 degrees. Okay? So solving a right triangle is that you know that you already have values, all right? And in this case, it means if I need to find 5 values, but it's not that you have at least one angle and one side, all right? This is one of the scenarios, all right? You have to be given one angle on one side. We are not taking into account the right angle because we know what it is, okay? So it means that you have 3 more values to find, all right? So basically, this is going to be about finding the three or other values that we are not given, because we have to provide you with 2 pieces of information, right? So this is scenario number 1, scenario number 2, okay? Of the segments, because we have infinite number of similar triangles having the same value for any, right? So that is not a possible situation to find, those values, those numbers. So keep that in mind. All right. So in order to solve a right triangle, you are either going to be given one angle and one side, or the value of the 2 legs. That's all necessarily. I want to be more specific with this. 2 sides, yeah, because I can give you 2. Okay, that's how it works. With this, sometimes you will have to use the inverse trig ratios. So inverse tangent, inverse sine, inverse cosine, okay? So with that, remember that you have to use whatever calculator, make sure that it's on degrees mode, not in radians mode. If it is on radians mode, it will give you different answers. Sometimes they are so similar that you won't notice, and you will get the wrong answer just because you didn't make sure that you had your calculator, or you didn't specify Google Calculator to provide you the answers in degrees. Okay, keep that in mind. So I'm going to do one exercise just so you know how it works, and I'm going to give you one type of exercise where I give you one angle and one side. Okay, so let's say, and we are going to solve this right triangle. One angle, let's say that the measure of B is 40 degrees, and let's say that A is, I don't know, 52, and let's include units, 52 feet. Okay, so what is the instruction? Solve the right triangle. What do I need to find out? I need to find out B, I need to find out C, and I need to find out A, because I already have the rest of the information. Okay, so if I have to find out B, C, and the measure of angle A, okay, let me tell you something. Let's go for the simple stuff. Okay, for example, what is this? What is the one that would be faster to find? Think about it. You already have the measure of one of the angles, the acute angles, and you know that this is a right triangle. So now you know you have information about these 2. So you're writing, you say, okay, well, here I have a 40, and here I have a 90, and I know that the sum of the interior angles of the triangle is 180, so this is 90, and 40 is 130, so this is going to be 50. That's it, right? So A is going to be something like that. 180 minus 90 minus 40. That's it. I didn't have to use any trick thing. I just found this one, right? Just as simple as that. Anyway, sometimes you will have to use the inverse trig functions, all right? So we're just going to make sure that we have the right thing here. And let's use a trig function to find that out. Before finding it, we need to find one of these two, okay? So we can do this. Let's try to find B, okay? B is this segment, which is the opposite to this, all right? Or the adjacent to A. Let's keep using 40, okay? So if I have the opposite segment and I have information about the adjacent segment to this, so we have adjacent, opposite. It means that we are relating tangent. So tangent on 4 over adjacent, which is B over A. B, I don't know it. And A is 52. You got it here, right? And remember, by the properties of equalities, I multiply by 52 on both sides because I want to know that B is equal to 52 times tangent 4. And then I'm going to run the multiplication. In this case, tangent of 40 is 0.8391. So I'm going to run it to 0.84. So what we have is 52 times 0.84, okay? And then 0.84 multiplied by 52, and that's it. It'll be 43.68. 43.68, let's say 43.7. This is B. B is a distance of 43.7 feet, okay? As you may notice, this right triangle is not drawn to scale because it is telling you that A is longer than B, but you know, we don't care about that yet at this point of time, okay? But now we already found B, we already found angle A. If you want to find C by using a trig, the hypotenuse, it's up to you. But I'm going to keep it like that because, you know, now I think that now you know how that works, okay? The last thing I want to make sure that I specify is because some problems in some of your homeworks talk about angle of elevation and angle of depression. So let's explain that, and then I think that we can call it a day. All right. Remember, as usual, this is all in video, so you can go back to it, rewind, and check that, okay? Actually, I'm going to erase this triangle again as well. We don't need it anymore. So angles are given, you know, with reference to something. So in this case, angle of depression and angle of elevation will be related to a horizontal line, all right? Think about it that way. So if you are talking about angle of, all right, let's say that this is a point of where you are, this is your point of reference, okay? Your vertex A. And sometimes with respect to this horizontal, and this is really important, with respect to the horizontal, we can have this kind of, or this kind of thing, okay? So as you can notice, with respect to the horizontal, if the line goes up, this is an angle of elevation, all right? Depression, all right? That's what you need to take into account. So that's how we get to solve exercises depending on the point. So we could solve an exercise taking that into account, all right? So for example, let's say that we have a man at volley, you know, it's kind of a volley of that, you know, it's kind of Sorry, I'm not a good drawer. I'm not good at drawing, but it's meant to be kind of skeletons or whatever. Yeah, sorry. Yeah. Anyway, this guy's over here, right? This guy's standing over here. Yeah. He's taking a look at the volley, and it's important to take this into account. Let's say that this man, and this is where the information comes from. Right as I'm describing this, I'm making up this exercise. So we could say, well, this man is standing on top of a hill, yeah, and he knows, right? And we can say something like this. He's using a drone just like Steve does, and he is using his drone, and the drone is right above, whatever the drone is, okay, here with a camera, and the drone is filming, and is right on top of the bones that the man sees over here. And also that he knows that the drone is, let's say 40 feet here, 40 feet. And the drone is 30 feet away. So with these two things, all right? So as you can notice, when we talk about this, it's important for you to understand what we mean with angle of elevation or angle of depression based on this. Hopefully this picture will help you. So let's see. I want to picture, and this is really important. You can imagine how the pictures go, and this is really important to model a situation. It's important to use imagination. And now let's find the distance between the man and the bones. Well, leg and leg, and this is the hypotenuse. So I'm going to say that this is C, and I'm going to say that this is angle. Let's say it's angle B. All right. So C is pretty much going to be square root of feet. That's why I erased and decided not to write 50 instead of 40, because now I'm thinking about a Pythagorean triple, but it's okay, to give an exact number. Okay, 50 feet, because I used Pythagorean theorem. And in the angle of depression, well, you can use any of the trig functions, either sine or cosine or tangent, because you have the measure of all the three segments. So whichever works for you is okay. Let's say I'm going to use tangent because we already have this information here. So angle B is equal to the inverse tangent, or arc tangent, as I like to use it as well, because that's how Google is accepting that to you. The arc tangent of opposite angle B is going to be 53.13 degrees, and then you're good. All right, and that's it. Just to emphasize on the concepts of angle of depression, let's say that now he makes the drone go up, I don't know, 100 feet above, this horizontal line. And if you want to find the angle of elevation, then you can work that out. All right. Remember, I am always available. If you have some doubts or something, you have questions, if you have any issue or something, just make sure you can email me. But as for what it means, I just walked you through this chapter 9. As I tell you, the test review, the practice test, is going to be posted on Canvas throughout this day. So probably you can check that maybe at 5 o'clock or something, maybe before, or no, maybe a little bit later. Yeah, maybe a little bit later. But anyway, you will have tomorrow and Thursday. And I'm going to hold another session to help out with the practice test on Thursday. So I will just let